knows you walk in. Welcome to the making of RoboKeith. I'm Puyan Agiat. Filming is Hadley Myers. We also have Steve Kiss, Meladri Roy, Omer Kalkan, and Andrew Gaddis as part of the group. We built an automated guitar player as part of our ELEC Cohen 490 end-of-year Concordia project. It all started in the summer of 2004 where me, Hadley, Neil, and Andrew got together and formed an idea. The idea was, quite simply, to play a robot that would play a musical instrument.
I heard about the project of RoboKeith. I thought, well, how are we going to put this all together? What are the designs going to be? And as we brainstormed and figured out many of the designs and how they're going to come together, I thought, oh my god, this is an amazing idea. And I was very, very enthusiastic about it all. And when it came together and we designed and implemented, it all worked out great. And I'm very happy with the final product.
Actually, it was Hadley that told me about it. He told me they were all building some sort of robot that was going to play an instrument. And my first thought was like, I've got to get into this.
Yeah, at first the idea came up and I didn't even think of the possibilities or how hard it would be, the mechanics and all that. I just thought, that's such a good idea, we have to do it. There's no question, we have to do it.
When I joined the group, I didn't know any of the guys, and I just heard about the project and it sounded good. And I signed up for it and it paid off. I was very happy with the work we did, and we're happy.
Bring it to my lab.
We were just sitting around, we came up with the idea, and at first it was like, yeah, that's pretty cool, and then it was like, well wait, how would we do that? And then yeah, all the ideas started pouring in and it started to look more and more feasible, and then here we are today. It was great the moment we came up with the idea. It's better now.
Another one of our demos. Ready to go! And there you have it. Dust in the wind. Eventually, the group grew. We were me, Hadley, Andrew, and Neil, as I said before. But we added two very valuable components. Steve Kiss, who took care of the MIDI, and, well, software in general, and Omer Kalkan, our microprocessor expert.
The four of us, being Puyan, Meladri, Andrew, and myself, have studied in a study group. We've had a study group together since first year of university. And so, you know, right away, even from first semester, we decided that we were going to do the 490 group sort of together, like as one foursome. But as conceptualization of the project began, we realized that there were certain areas that we really didn't have a great deal about, and that we had, we were fortunate enough to have friends that had a certain expertise in exactly what this project needed, exactly what we were having trouble handling. So the first person that we decided to add to help us with the layout of the board and the microcontroller was Omar.
So yeah, the first time that I met Omir was in my Impact of Technology class, where he was actually in my group project, Check, and we got to talking. I explained to him our idea for the 490, and he was, pretty impressed and was excited about it. So he took me to his house one day, and I saw these microprocessor components lying around, and it all seemed pretty interesting, and he seemed to have a lot of experience with this stuff, and it was exactly what we needed. So I asked him if he wanted to join the group because he'd make an ideal candidate. He said yes right away. He was super thrilled about the idea, and that was it. He was in it.
Yeah, the original idea was to have only filters, so no microprocessor involved. Well, very minimal microprocessor theory involved, and we basically added him on, and thank God we did, because he helped us out a lot in the end.
Check.
We had a little bit of trouble dealing with some of the more complicated aspects of software, none of us being in Cohen, being computer engineering students. And so, I had been friends with Steve for years, since CJEP. And so, knowing what he was doing and knowing what he was into, and also that he was a pretty accomplished musician, the choice to include him just seemed natural.
Yeah, so one of Hadley's good friends, Steve Kiss, we actually all knew him before, but Hadley told him about the project, and he showed interest, and he was a computer engineering. Well, he is a computer engineering student, and we said, well, we knew that the project was heavy on the software and programming, so we said maybe someone like that might help us. So we told him about it. We had a few meetings with him, and he kind of jumped on board, and
Yeah, that was it. From there on, we had Omir, Steve, Hadley, yourself, Puyen, myself, Neil, and Andrew. That was the six of us, and we made history there, right? Built RoboKeith, and it's the success it is today.
Yeah, well, that's where it all started.
And in our quest for a supervisor, we interviewed a lot of people, one of them being Ted.
Here's Ted, another supervisor.
And after agreeing that Ted would be our supervisor, because of the extent of the project and everything that was involved, we thought it necessary to have a second supervisor, and that's when we started talking to Costas.
Our supervisor, Costas.
And that's how the whole group came together. God damn it.
Next up, a very famous Fur Edis, another classical piece. We're ready to go? Let's roll.
Alright, that was Feliz, and we'll move on to the next.
We ended up dividing into 3 components: mechanical, software, and microprocessor. Me and Neil went on the mechanical, Hadley and Steve on the software, and Omer and Andrew on the microprocessor. It is now 8 months removed from that time, and the project is completed. The guitar is functional, and we've accomplished what could be argued as the best project in Concordia 490 history. January 18th, date of the first milestone, phase 2 report, where the guitar played something for the first time. Only half the robot was built, and we only played 1 song. It was nonetheless a critical milestone.
And the most important part of the project, obviously, the Keith Richards bobblehead, which is integral to our success. And there we have it. Are you ready?
Yep.
So here's
Where's KB?
the first.
Hey, sorry guys, we're going to have a bit of interruption with some noise, so just please bear with us.
First time playing No Surprises with Nick. Plug into that now.
So are we ready?
Does it work?
Let's hope for the best. Oh yeah, that's Andrew. He's working with he's working with Omer on the microcontroller / hardware. So there you have it. Only half. The other half will go on this side, obviously. The board is removable now, so the room is not a problem at this point. How much longer, Omer? Okay, well, it looks like we have a few minutes, so I'll explain the little genius removable pivot bar here. As you can see, the bar is held across by 2 blocks of wood, but the neck is directly under the fingers. So how you remove the guitar, you ask? Well, that's the genius part. You can easily see here how this side of the wood has only 1 hole in it, whereas that wood has a whole slot through it. So Neil here is adjusting a bolt that could be removed. Once removed, the bar can slide out on one side, and all the fingers are removed, making the guitar free to come out. The pluckers are already removable. Okay? Watch the yep. Thanks to this blocker that could be removed, and all these fingers come out. Are you ready? Alright, here we go. One error, which we will correct here. I got it. Yeah, you got it. And there is a semi-successful run.
Play it again.
Well, hold on. Don't play it again yet. Here, Neil, you hold it. I'm playing the bass part.
We got all live interested now.
Okay. Hold on.
Ready?
Go. First successful run.
The robot itself involves many mechanical components. There's harpsichord jacks.
Yeah, obviously we had no experience when it came to mechanical robots or anything like that, so we actually went through a lot of preliminary designs. We even had one, it was pretty expensive, we went through a bunch. One of them even had like a little rolly thingy with a conveyor belt. I don't know what we were doing, but at that time we didn't know. So we're basically going through all the possibilities, trying to figure out what's easier to build, what would be most precise, and makes a nut mix without regular peanuts. Anyways, what was that? Oh yeah, the pluckers. So yeah, the pluckers we had a bunch of designs for, and finally Hadley had this friend who knew this guy who manufactured harpsichords,
And harpsichords have these little jacks that basically work vertically and pluck the strings. It's all a little intricate design. And we went to see him, and we asked him if he can sell us some, and he sold us only 6, and 6 is pretty much what we needed because of the 6 strings of the guitar. And yeah, went from there. Those jacks were perfect. They saved us a lot of time in design, and they're as precise as can be now. They do the job. There is flickers, fingers, and the fact that the whole guitar is removable.
So yeah, the solenoids, man, those are the best. We went to this store, Aber Electronics, and they just had them lying out in front as their surplus, and we asked them, you know, how much are they going to be? And as it turns out, they were $1 a piece, when usually on the internet they're like, you know, 5 to 10. And it was exactly what we needed. We found the power supply that worked for them, and the design, it just worked out for the pull types, and that's why we got them.
Actually, yeah, one thing that's really good about the guitar is the fact that, well, the guitar robot, is the fact that the guitar is removable. I mean, you have all these fingers and pluckers all over the guitar, and you think, you know, this is not really practical, but in fact, every piece in the robot is removable. Like, you can just lift, I know it takes unscrewing, it takes removing stuff, but the fact is, if you wanted to, you could remove it with the guitar. So if a string breaks, or you wanted to tune it manually, or I don't know what you want to do, it's all fully removable, and that kind of came about as we were designing it. It wasn't really something that was planned essentially from the start. It's just something that was accounted for step by step. So yeah, we're happy with that feature. It's something that we're proud of, and we're really glad it's in the design. Really, you know, eased the process.
If you haven't recognized it so far, it's the intro to Metallica's Fade to Black, one of their early classics. Remember, no hammer-ons and no pull-offs, so keep that in mind. Little long intro. And there you have it, Fade to Black by Metallica.
It's amazing.
Communication is done through a microprocessor, which is built along with its components, resistors, capacitors, all that jazz, onto a perforation board.
Well, as far as time goes, it set us back, and we have some glitches in between when we try the testing that some solenoids come on when they're not supposed to. It's because the thick wires that need high current to go through them touch each other. So perforation board, as far as nice looking goes, it helped us a lot, but it set us back as far as time goes. So we would have been better off with other solutions, but we took it, we voted, so I think we can keep it.
The software is the interface that was created so that any user can use the robot and pretty much easily compose, real-time test, load MIDI, and whatnot.
The initial ideas were make some sort of composer. My main concern was, how can we get it to play pretty much anything? How can we get it to play all the songs we like without having to worry about programming them ourselves? The answer came from an unexpected source. A friend of mine was taking a class on MIDI at McGill. He started telling me about it, and I got interested. The more I heard, the more I wanted to know, so I went to see his professor. He told me it was exactly what we could use. It's a format used to coordinate synthesizers. It's been around since 1982, and virtually any song is available out there in MIDI format. So that became our next goal. We started building it.
To achieve this, a certain GUI was created.
Well, as for the GUI, which is the graphical user interface of the device, we felt it was necessary only as a means to allow people to play it, or to play with it rather, easily. You see, it's a guitar playing robot, and playing guitar is very difficult. This makes it easy. Anyone can use it. That was the main point of it, was usability, and I personally feel that it's a lot of fun to use, and very easy, very simple, very clear what all the buttons do.
Here we have a view of the GUI / composer interface we have created for RoboKeith. You can see here is the I don't know if you can see it in the screen if the brightness allows, but it says conversion of intermediate format complete. And that's obviously a picture of Keith Richards, and that is a picture of Keith Richards. Here you have all the chords and rhythms and notes you can play. And you just go in and press the little add, load, clear, whatever you want, and play. The songs are loaded using these buttons. Again, I don't think the brightness allows you to show it. Let me see if I can reduce the brightness here. You might be able to see it there, or that one. There you go. Conversion of intermediate format complete, or intermediary complete. Here you have all the notes, one by one. E to D, you can choose any note or chord you want. Flat, natural, or sharp. You have note, major, minor, major 7, all the different varieties, as well as all the differences. For example, down, down, up means down, down, up, and so on. And you place load, add, whatever you want, and play. Scroll bars to determine the length of sound that are being played. Here are real-time tests for tuning, all 6 chords. And there's the load button, although I doubt again that you can see it.
It can play virtually any chord there is, any quality of chord. It knows a whole bunch of rhythms, and absolutely anyone can walk over and program a song. If you have the patience, you can program almost any kind of song. Well, from the graphical user interface, you're able to type in the name of the song in MIDI. From there, it displays a list of tracks. You can select one of the tracks to load to the microcontroller and play it. There are taskbars that allow you to set the start and stop times that you can play for. There's also a loop button and of course a stop button. Furthermore, the composer section allows you to click on different notes and chords and variations and then add them with different rhythms and then send that whole thing to the microcontroller and play it. It's a lot of fun to play with, very simple, and I hope everyone enjoys it.
So now we have a signature Rolling Stone song, Satisfaction, and here we go. And that's Satisfaction. Okay, I think that's the end of it.
Also, a lot of MIDI parsing had to be done. MIDI parsing involves basically changing the song, adapting it so that the guitar could play it, because it was limited to the first 4 frets, as you know. Here's a better explanation of that.
Okay, the reason we're doing parsing is because of the actual instrument we're using. It has to do with what notes it can play and how fast it can play them. So basically what we're inputting to the parser is any piece in the world. It could be a symphony, and the parser brings it down to the point that the actual physical instrument plays it. So the two things in question are the actual notes that are to be played and the actual timing of solenoids, the actual time that we need between notes that are to be played. So when we look at the notes that are meant to be played, we look at all the notes that could be played. We look at all, for example, on one string, we could end up having 4 notes that need to be played. So we got to look at these notes and say, okay, this note has already been played, we're not going to select this note. This note is lower, this is a low string, we're going to select this note. At any point, such resolutions are solved. Am I making any sense?
It was a little bit of a mad rush in the end. We had about a week to do the report, which was quite hectic because we only found it out very late.
Well, about 2 weeks into March, Omer finally randomly just checked the website and we realized, oh no, the report is due in a week. It was, I believe, the 13th or 14th of March and the report was due the 21st, a Monday. So right away we got together, organized an emergency meeting, and divided up the tasks, divided up the sections. We had many, and we knew it was going to be pretty big. So we set like a Friday night, I believe, Friday 6 a.m. deadline, so that we can edit it over the weekend and have it all done. We all went our separate ways, got our parts done, even though we only had a week left, and there was a lot to say. It ended up being pretty hefty, and we got it done though. So the only annoying part was that this report was due on the 21st, and the presentation was on the 30th. Which is kind of weird because the report you would think comes after the presentation. So we were in that testing phase and adjusting and still running programs and writing new stuff. And we had to put all that on put it on hold and start working on the report, which was, you know, kind of annoying.
But then came the last few days of the report, where Puyen and I had to put all these parts together, right? And we were just in awe at how big it kept getting. It didn't end, you know, we'd get Omer and Andrew's part and it got massive, and then Steve's and Hadley's part, and that was equally massive. And then we got Hadley and Steve's appendices, which was, I think it was 81 pages to the dot. It was unbelievable. I couldn't believe it personally. Puyen kept saying don't worry about it, but yeah, so it kept getting bigger and bigger. And then came the problem of printing it. Where are we going to print this? It was Sunday night. We have no places open. We didn't know that there were 24-hour places. So finally we relied on Puyen Monday morning finding a place that would print it on the spot. And I mean, look at this thing. It's absolutely ridiculous. It cost us about $91, I think, 95, something like that. But I have to say that this is something that we'll all keep, and the color pictures came out so well. It's a perfect guide of how RoboKeith works. You can't say anything better than that. It came out well.
Turn on the amp, please.
Yeah, right.
And there you have it. Once again, song is cut short. That was green sleeves. And ready to load the next one.
Despite the original plans, in the end we had some sort of hearing certainty going. It wasn't really the functional hearing circuitry of 29 notes we had hoped for, but it was still better than nothing. Integrating filter designs and wave theory into the project.
So, yeah, believe it or not, the hearing circuitry was actually going to be our 490 by itself at the beginning. It was just going to be some way of making the robot hear sound and then play the same stuff back.
But then we noticed how extensive each filter design would be. We created 29 of them, 29 notes. It would have been quite a hefty
Undertaking.
Yeah. So we decided to cut it down, and it became our last priority. And at the end, we ended up doing a guitar tuner, where we only had to make 6 filters and output into LEDs, little lights. And when we're in tune, when each string is in tune, its respective light would turn on. And that's how we cut it down without eliminating.
I mean, it's a simple idea and it's a pretty rudimentary tuner, but it shows, proof of concept. It accomplishes what we wanted to do, which was adding some sort of analog filter design component to the project, and we did that.
It's good.
Does the filter work in the end?
Does it work?
Does the filter work? Just talk about how if the filter doesn't work completely but still does something.
Well, what we've noticed about the filters is that they don't all work in the same way. They all catch it at the right frequency. However, they don't all output at the same voltage level, which sort of leads to a difficulty in getting proper tuning guidelines, because we're never sure if it's dead on or not. It's inaccurate.
Sadly enough, all good things come to an end. We have now reached the end of RoboKeith, and the guitar is fully built, fully cased, fully functional, and it's being stored right now at Omer's place. Tomorrow is the presentation, the final presentation at Concordia. It's been a long journey. We've had a lot of laughs, a few cries, lots of pain, lots of work, but in the end it was worth it. We accomplished something no other group has accomplished so far.
This is definitely one of the coolest motors out there. Incorporates a lot of components. That's what is very interesting about it. Incorporates software, hardware, some mechanical work, and a lot of sound. I want to say good work to all the guys that participated. The experience has been valuable from the design aspect and from the supervising aspect. Thank you very much.
Why do I think RoboKeith is cool? Well, you did a good job. It works. Plus, it's the coolest project around. Just is. Like the whole idea that you have a guitar playing by itself under microprocessor control with the MIDI interface. You did good work. It plays in the end, and that's what counts. So all your hard work finally comes to fruition. I'm proud of you guys.
I think it's about time we go get a good look at this robot of ours. A good robot playing guitar, fully functional. It's being kept at Omer's place, like I said. So why don't you follow me and we'll go have a closer look.
Well, it's March 28th, 8:15 at night about, Monday. And the presentation is on Wednesday, and we've just finished cleaning it up. As you can see, we're all here, we and filming, and we're about to test Street Spirit by Radiohead, see what happens. So, Steve will just press play.
Where did he graduate?
Second song, or?
Use the bass for me.
8 times. 10 times. That's 7. That's 8.
What else is good that it plays?
Well, we'll see.
Yeah, do it, do it.
So that was Street Spirit. Radiohead.
Yeah, why we
I mean, I couldn't believe how massive it was. With the file, my computer kept crashing. It was so massive. Like, it was unbelievable.
And that's how the, sorry.
Okay, last take.
Okay.
Are you still recording?
I should stop it.
This too?
I'm recording now, so stop screwing around.
All files. This one. Open.
Michael, uncross those eyes.
Okay.
That was going to be involved, and we actually had a lot of even rolling things going, like one with a conveyor belt or something, and we basically mix a nut mix, not regular peanuts.
That's how we deal with trouble.
We need for how long, an hour?
Right now, yeah. An hour.
At most an hour.
I heard something about a hearing circuitry. What was that?
You guys just talk about your hearing circuitry part, remember?
What? I didn't quite hear you there.
Give me some secrets for that.
It's,
Too many years of exposure to rock and roll.
Alright.
I didn't hear the beep.
It's on.
Okay.
That's for sure a blooper.
Alright, yeah.
Missed it. Too far in. Still higher.
Can I drop it?
Cool. No. Back it up. A little this way. Okay, go.
Like half the song or something.
This
You
is
know
a
what
look of
else?
concern.
I'm gonna
Look of failure.
build this now, and it's not gonna build.
So yeah, Almir was in my management.
Well, first explain what you're explaining.
It's a lame.
You gotta put that in there.
I think you can stop taking.